This is lesson 15, adding the angles in a triangle. And this is activity 1, which says, can you draw it? And so what students are supposed to do is to draw each triangle that goes into each of these cells. Well, I already placed the triangles in the cells for you. I think this is supposed to be a warm-up activity, but this takes much longer than just a warm-up. So my suggestion is to go through and look for patterns as students work down the rows and work across the columns. And so what are some patterns that can be developed so they understand what's going on as they draw these different triangles? And so as you work down the rows, the comparison is the number of equal sides. And so it begins with one equal side, which is a weird way of saying that none of the sides are equal, but then two equal sides. So one equal side equal, one side length equal, two side lengths equal, or three side lengths equal. Now equilateral actually means equal side. Lateral is another word for side, so equal side. So as you go down the rows, the comparison is to the lengths of the sides. Either one side equal, two sides equal, or three sides equal. We'll come back to isosceles in a moment, but as you work across the columns, the comparison is to 90 degrees. Either the angles are less than 90 degrees, one of the angles actually equals 90 degrees, or one of the angles is greater than 90 degrees. So across the column, acute, right, and obtuse has to do with the size of angles. Acute angles are less than 90 degrees, a right angle is equal to 90 degrees, and an obtuse angle is greater than 90 degrees. And then once again down the rows, scalene is one side, or none of the sides are equal. Isosceles. So isosceles is an interesting word to learn how to spell. It's S-O-S, isos. So just think of S-O-S, and then it's celes, C-E-L-E-S. Isosceles. And that means that two of the sides are equal, and then equilaterals, all three of the sides are equal. All right, so let's look at actually a scalene triangle where all the sides are different lengths and they're all less than 90 degrees. It's kind of a normal kind of triangle. It's probably the triangle that most students would draw most often. If you just said, draw a triangle, you probably would draw a scalene triangle. Now, an isosceles triangle has two sides that are equal in length. If you have two sides that are equal in length, then you also have two angles that are equal in length. So two sides are equal and two angles are equal. So these two angles down here are going to be equal, and they have to add, these two angles that are equal have to add to greater than 90 degrees, because the third angle has to be less than 90 degrees. So if these add to greater than 90 degrees, but each one then has to be, it's going to be less than 90 degrees, you're going to get three angles, all of which are less than 90 degrees. So let me try to say that again. Two angles that are equal, they have to add to an amount that's greater than 90 degrees, because they have to make up the difference for this one angle that's less than 90 degrees. And so if you have that, two angles that are greater than 90 degrees, they can't equal 90 degrees. Well, actually, let's just leave it at that for right now and see what happens. So the third angle had to be less than 90 degrees. Now, as this angle at the top here opens up farther and farther and farther, if I work across this way just for a moment, eventually it's going to be equal to 90 degrees. So right here it's equal to 90 degrees. Both of these angles then have to be less than 90 degrees, and this is an isosceles right triangle. So a right triangle has a 90-degree angle in it. We're going to come back to this in a minute. But if these two angles are equal and this angle is 90 degrees, then these two angles have to be 45 degrees. And then as that angle opens up farther and farther, now it's greater than 90 degrees. That means that these two angles have to be much less than 90 degrees. They're equal, and they have to add to values that as this angle gets larger and larger and larger, the sum of these two angles is going to get smaller and smaller and smaller. So they're going to be smaller angles that are equal. All right, down to the next triangle. Three angles are equal. Up here we had two angles, or two sides that were equal, gave us two angles that are equal. Here we have three sides that are equal, and that gives us three angles that are equal. Well, if all three angles are equal, they have to be 60 degrees. So an equilateral triangle has three side lengths equal. It also has three angles that are equal, and those angles are 60 degrees. You work across, you can't have a right triangle because the angles are all 60 degrees. You can't have a 90-degree angle. And you can't have an angle that's greater than 90 degrees because all three of these angles are 60 degrees. So an equilateral triangle that's a right triangle is impossible, and an equilateral triangle that's an obtuse triangle is impossible. All right, so let's go back up here for a minute. This is a right triangle. It has a 90-degree angle. That means that these two angles have to be less than 90 degrees. And the main point of this lesson is that all the angles of a triangle always add up to 180 degrees. Well, if this angle is 90 degrees, these two angles have to be less than 90 degrees. Because they have to add together to actually equal 90 degrees. All right, so now let's compare it to what happens with this triangle down here, the isosceles right triangle. So this is an isosceles right triangle. And so if I go back up to this triangle, and if I make this side longer, I want to make these two sides equal in length. I want to make them an isosceles right triangle. So I have to make this side longer, and that means that this side has to become shorter. Now what happens to the size of the angles as you do that? Well, if I draw a parallel line here, and if you look at the size of this angle, this side is moving up. What's happening to the size of angle right here? It's getting smaller as this size gets longer, because it was on this parallel line. It was right here, but now it's less than that parallel line. So this angle is getting smaller. Well, these two angles have to continually add to 90 degrees. If this angle is getting smaller, what's happening to this angle down here? Well, as you move in and make this side shorter, then this angle has to get larger. So here's the parallel line for this one. And as you make this shorter, this angle moves from this parallel line over here, and this angle gets larger and larger and larger. And you can think about it, if you keep moving this in farther and farther and farther, this angle has to get larger and larger and larger, and this angle is going to get smaller and smaller and smaller. So all I really am trying to get you to see and visualize is the play between those two angles. As one gets larger, the other one has to get smaller. They always have to equal 90 degrees because this angle is 90 degrees. And so 90 degrees plus 90 degrees equals 180. So they always have to add together to equal 180 degrees total. All right, this is now an isosceles right triangle, so this is 90 degrees. All right, let's take just one last look at what happens over here. This angle is greater than greater than 90 degrees. So it's an obtuse angle. That means that these two angles have to add together to a value less than 90 degrees. So these two angles have to be small. They are acute. They add to an amount less than 90 degrees. And what happens as this angle gets larger and larger and larger, so right here, this angle is getting larger. So these two angles have to get smaller. Because again, these all have to add to 180 degrees. As this single angle up here gets larger, then these are equal angles. This is an isosceles triangle. So these two sides are equal, these two angles are equal. So as this angle gets larger, these two angles have to get smaller. It is confusing. There's a lot going on. That's the reason that this is not really a warm-up. This is a pretty detailed activity. So I would go through each of these and see if you can start to form an idea and understanding. Write some things down, take some notes of what's going on as you change the lengths of the sides and make two sides equal, three sides equal, and what happens this way as you change the size of the angles, make them less than 90 degrees, make one angle equal to 90 degrees, and make an angle larger than 90 degrees. What has to happen to the other two angles as you do that, and you go through this activity and do that thinking, it will start to make sense to you. It's pretty tough one time through. Okay, lesson 15, activity 1. Okay, I wanted to add a little bit more on the isosceles right triangle because I realized that what I did earlier is I made this side shorter as I made this side longer until they were equal in length. Well, you don't really need to do that. I think an easier way to look at it is to look at both of these lengths as a radius of this circle. Once both lengths are a radius of the circle, they are equal in length, and this will be an isosceles right triangle. So what I did is I increased this length until it's the length of the radius. Once I do that, it is an isosceles right triangle. So this last length right here, and with this last pink side, that is an isosceles right triangle. And so the question is, what happens to the sizes of the size of this angle as this length gets longer, and what happens to the size of this angle down here as this length gets longer? And I added these parallel lines because that is the original size of the angle. That's this parallel with this side right here. So all of these angles are congruent. I just translated them up. They're all congruent. So then we can look at the difference between this angle that goes along the blue parallel line there and the new angle that's going to go along this pink line each time. Let's take a look at what that looks like. All right, down here I colored, as these angles increase in size, I colored them different colors so you can see it. And I realized that if I put a square right here, well, the diagonal of a square is 45 degrees. So as this angle increases in size, once it matches the diagonal, that angle is 45 degrees. That has to happen if it's an isosceles right triangle. If both lengths are equal in length, both of those angles are the same size. The third angle is 90 degrees, so the other two angles together have to equal 90 degrees. Well, half of 90 degrees is 45, so each one of those angles has to be 45 degrees. So as that length on the right side gets longer, this angle gets larger, and it becomes eventually, it equals 45 degrees. But what happens on the right side? That also has to equal 45 degrees. But here these angles are larger. So as you go up and have longer and longer sides, this angle is going to get smaller and smaller and smaller. So I'm going to zoom in each time and show you how that's happening. So this is the original triangle. This is the original angle, and it's substantially different from 45 degrees. This diagonal right here would be 45 degrees. This angle is opening up substantially more than 45 degrees, maybe up to 60 degrees. So I'm going to zoom out just to show you where I am, and zoom back into this one now. Now notice that this angle is smaller. Well, this is the original angle right here, the blue line. And now the difference is this amount right here. So this angle is smaller, and it's starting to approach 45 degrees. So it's going from about 60 degrees to, and eventually it's going to end up here at 45 degrees. So you go another square up, another triangle. It's even farther away from this line, and it's even closer to the 45 degrees. So this angle is getting smaller. And eventually, once it's an isosceles right triangle, this angle will equal 45 degrees right here. It's getting closer, and it's getting a little bit messed up because it's getting tight. There's a lot of lines and squares in there. But just look at the purple square. Look at this pink line right here. This angle is almost 45 degrees. The original angle is right here. So now it's decreased by this much in size, and it's going to decrease a little bit more as it reaches an isosceles right triangle. This is the diagonal right here. That will be 45 degrees, and finally, it is 45 degrees. So again, this is the original size right here, so it's decreased by this amount, and it's and the angle now is 45 degrees. It is the diagonal of the square. So as you increase the length of this side, this angle gets smaller, 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 and up here it's 45 degrees. and it's an isosceles right triangle, and as you increase the length of this side, this angle gets larger, 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 until it is 45 degrees. And I just want you to see that play between those two angles. Well, this angle is 90 degrees. That means if you make this angle larger, then this angle, set it backwards. If you make this angle larger, you have to make this angle smaller so that together they continue to equal 90 degrees. And for an isosceles right triangle, both angles equal the same amount, which is that 45 degrees. So hopefully that's a little bit better. Take a look, think about it, try to go through it in your head, and understand what's happening.